Day 5 will review our different methods for solving systems. So in the first example, we will solve the system by graphing. Remember, a system is two or more equations with the same variables. So in our first example, we'll graph, since they're already in slope y-intercept form, or slope-intercept form, we'll find the y-intercept, which is the number by itself. So in the first equation, it is 2, and our slope is -3/2. So we'll start at 2 on the y-axis. We'll go down 3 to the right 2, and that will give us our negative slope. If you want to go up, you'll have to go to the left, and then we'll connect those points, make a line. Okay, so there's the first equation. The second equation will start at -2, and it has a slope of 1/2, which means we go up 1/2, up 1/2, connect the line. That line's not great. Oopsies. Okay, and we can see our point of intersection. So solving a system is finding the point of intersection, and that is at 2, -1. So solving a system is finding the point of intersection. Number 2, solve the system by substitution. You can and should check your answer. All right, so right here, x equals 13 plus 2y. So everywhere we see an x, we're going to go ahead and plug that into the second equation. So we have 5. Instead of x, we'll put what x equals, the 13 plus the 2y. And then we'll write the rest of the second equation. So plus 5y equals 20. And then we'll solve. All right, so 5 times 13. We have 65 plus 10y. When we distribute, plus the 5y equals 20. Combine like terms and solve. So we have 65 plus, we'll combine our y's here, 15y equals 20. Subtract 65 from each side. 15y equals -45. Divide by 15. So y equals -3. Remember, we're trying to find the point of intersection. So now we can plug into any of the equations, and usually there's one easier to plug into than the other, and here's the one that's easiest to plug into because we need x. So we'll plug into that because we know y is -3. I put just 3, but it is -3. All right, so we have x equals 13 plus 2 times -3. So x will equal 7. All right, now we can check our answer. So this point of intersection is at 7, -3. To check our answer, we can let's plug into the second equation and just see are both sides equal. So we have 5 times 7 plus 5 times -3. We check, does that equal 20? So we have 35 minus 15, and yes, that does equal 20. So you can and you should check your answer. So point of intersection 7, -3, and that's using substitution. All right, 3, solve the following systems. Okay, so this one right here, this will be elimination. To solve using elimination, we have to pick a variable to get rid of. So I'm just going to choose the x's. You could choose the y's as well. All right, so I'll choose the x's, and we want to think, what's the smallest number that 4 and 6 both go into? Because we want to make them match. So I'm thinking 12. They both go into 12. So what do we multiply the 4 by to make it a 12? And that would be a 3. What do we multiply the -6 by to make it a -12? And that would be a 2. Let's change colors here. All right, so let's go ahead and distribute. You distribute to everything inside the parentheses. So we have 12x minus 12y equals 24. And then we'll distribute the other one. -12x minus 20y, or plus 20y, equals -32. Okay, so now we do the elimination part. Since the x's match, we can cross them off. We can add together our y's. We get 8y equals, and then 24 minus 32, combine those, -8. Divide each side by 8 to get y by itself. Whoops, not -8. So y equals -1. Again, we want the point of intersection, so we're just going to pick one equation to plug into. I'll just plug into this top one here. We know that y is -1, so we have 4x minus 4. We'll plug in the -1. That's going to equal 8. And we'll solve. So we have 4x plus 4 equals 8. Subtract 4 from each side. 4x equals 8 minus 4 is 4. So x equals 1. So these two lines cross, and they cross at the point y, or 1, -1. And then we can check our answer by just plugging in. So I'm going to plug into the second equation, see if those are equal. So if we plug in, we get -6 times 1, which is -6, plus 10 times -1, which is -10. Does that equal -16? And it does. So these two lines cross, and they cross at 1, -1. So in class today, we're going to play an add 'em up game to review substitution and elimination, and your assignment will be to log into Delta Math, and you'll be doing the solving systems review.